Welcome to a new test and teardown video. This time it's another function generator. This one is from GV INSTEK. Model is GFG-8015G. So this one is actually a little bit defect, but it's a minor. So I think I will be able to fix it. It can handle from 0.2 to 2 megahertz because each range has a quite nice way they do this. So they're talking about the center of each range. So I'm now in kilohertz, and so this one goes to 2, and yes, we got 2, and then I can dial it down to 1. Let's try and see how accurate it is. So that this is 1, and then it is 103. So that's only 3%. I mean, that is quite all right. So what I want to show you is it's a mechanical defect I got here. See, I can't switch this one into sine wave, and but if I click the other switches so they go out, and then I push and hold the sine wave, see, I get my sine wave. So I mean, electrically it seems to be working, but there is some switch stuff here that is not working. I will have to see if I can figure this out. We also got a few other minors. This is the amplitude. Look at that. So this is potentiometer noise. This is a quite normal problem with generators this age. So you can easily find all sorts of places where the potentiometer is not working. Let's put it all the way up. So let's try the DC offset. Yeah, I think you need to pull, and then you'll enable your DC offset. And you can see here, it's also full of noise. Quite useless. And then we have a duty cycle. So that seems to be filtered. Yeah. I don't know if this is shown on the video, but there is a delay. So I mean, this output here is nicely filtered. We got a voltage control input. That is of course to fine tune or remote control your output poles. That is probably just for a start, so there's a trigger. Yeah, other than that, I think it works more or less. I went through all the different ranges. All those seems to be spot on. Other than that, I can say it's a really funny looking case. This looks like something from a spaceship. I don't know. I mean, this really weird. And there's nothing. Oh, come on. Oh, difficult. There's nothing here on the back. Just power input, 11 watts. Yes, I can also tell you that the on-off switch is after the transformer. So that means there is a small idle power usage. Let's just plug this in and see. It's using 8 watts when it's powered on. And now it's off. It's using 1.4. So that means the transformer is energized, but the rest of the unit is clearly off. It seems fairly easy to open this one. So now we're inside. The first thing I did was to give all my 4 potentiometers some contact 61, and it just did absolutely amazing wonders. Try and have a look here. So this is the output DC offset. Handles the entire range like that, and then output power here is now smooth. Absolutely wonderful. And I gave all the 3, and there isn't any electrical differences here, but it feels better because it runs more nicely. Let's look a little bit on the internal electronics here. So the first thing I noticed, that is the power supply. It's just a little bit normal. Rectifier, capacitors, ooh, don't touch here. That's the high voltage input selector. And it was correctly set for 230. So that is good. It looks like somebody did break it from its solder point. See the glue? Yeah, glue there was for 220. And then, of course, we got up to 230 quite a lot of years ago. But it was adjusted. Then there'll be the voltage regulators, and they're made with Darlington transistors and op amps and Zener diodes and all that kind of stuff. So clearly all this stuff here is related to power supplies, individual potentiometers and all that kind of stuff. And it's not crazy warm yet, but in many signal generators you find the regulators tiny and very, very warm. I mean, I've seen this a million times. And then the output amplifier, since this goes all the way to 2 megahertz, it's of course DC coupled. It's supposed to be DC, right? Or handled also very low frequencies. That is also a place where you'll find the output stage and the driver stage is like really, really warm. But it's not bad at all. It's acceptable. I can see we got some tiny little parts down here, Zener diodes, and they run a little bit too warm, I would say. I think it's the classic circuit with some op amps and stuff like that. This is a CA3086, and the rest just normal op amps, not a lot of fancy stuff here. And again, all those diodes like that and the resistors, I believe that is a sine wave converter. So that means when you see this is a broadband sine wave converter, and you can actually see the way that this, let me show you if I can make it go into sine output, and let me see if I can zoom it somehow. That is a little bit weird. I was hoping I could show you the side effect of using this sine wave converter, because there's normally a little tippity tip here at the top where it goes from positive to negative in this diode converter system, but I'm not really able to see it for some reason. Maybe they have a little variable filter they enable when you change this, when you change from the different. Oh, this is my switch that is not working. So when I poke around with that one, I don't see that little funny dot. So now I have to figure out how can I change the problem. How can I repair this? I think I need to pull the entire unit to pieces. See, the circuit board is not really, yeah, it is, there's supposed to be a screw. Yeah, okay, that will be the screws for the mains, but the rest is, it was mounted using those dog bone type of plastic things. So they go here, click, and then they go to the top, and then ultra long screws. What is that nasty? That is not good. When you see some, that is some corrosion splatty splat in that area there. So where is that? That is in the top left. Aha! It's this. It's because this is down. This is not up, this is down. So you see, it's upside down, right? So that means when they are running this kind of, I don't know, chemicals or glue or whatever. It kind of drippity droppity. Ooh, I can feel this is really nasty on my fingers. That is not good. This is a little bit funny. So this is the transistor cooling compound. See? It turned itself into some sort of a nasty dust just by touching it. I was trying to see if I could measure some connectivity in this. The fun thing is that it has probably been wet at some time, some 20, 30 years ago, and then it dropped down here and created some corrosion on the aluminium foil. So that means it did contain some sort of acids, and the kind of stuff that was here, when I touched it, I could feel on my fingers that it was some nasty, not so nice chemical stuff. So now we'll have to clean this a little bit. And here's the bottom of the circuit board. There's of course connections to this type of metal. The bottom plate of course also got this. So this turns the plastic case into a metal case. But what the heck is that? Some nasty dots around the transformer area. I'm not happy about that. So I'll have to clean that a little bit. What else? There's also some funny soldering around that. And so that will be the switch section I need to poke around with. So this one is the duty cycle, square wave, triangle, and sine wave that is not working. They are in one combined shadow switch, and this is the attenuator that is in a standalone switch. So to get in here I need to desolder these and take them all out in one unit, and then I will see if I'm able to fix it. That is not so easy, as you can imagine. And it is because we have this little thing that moves. It is actually possible to see some of it if you look down right here, okay? See when let me see if I can make a good setup for that. Here we go. Look down there. So there's a tiny little piece that moves. See? So this is the reset part that moves, and this one was supposed to be having some sort of effect with the sine wave, and there is no effect somehow. So there's a little part that is broken. I'm probably not able to fix that, but we will see what I can do. So far I got a unit that is definitely of no use at all, since this is not working. So what can you do? Either you have trash, or you try and fix it, and then if it doesn't fix, then you still have trash, right? But at least I got these two working. That could also just be something that I just accept. I don't know. What should I do? I want to get in here somehow. So now I need to take away all the connectors and separate this unit. So there's another little detail here. Always document different connectors. So this one got 6 connections, but the cables from this front panel here, they're not able to reach all the way over here. There's another 6 pin. So I mean, it's impossible to do this wrong. But there's also a 2-pin connector here, same style of connector down there. But again, if you don't remove these little cable ties, there's no way you can do this wrong when you assemble it again. So here is what I'm doing. So I'm using a tin sucker and suck out as much tin as I can. And when I think I'm done, I take my soldering iron here, and then I just carefully push each of the little pins a little bit to the side, tip, and then it gets loose from the soldering, so there's still a little bit of solder in the holes, as you can probably see. And now everything is cold. Then I take a little tweezer like this and then carefully check. See, all of them, they are loose, and I went through it like this. So I think I should be able to pull out this entire section of the shadow switches. See, the goal is to make sure that all pins are as free as you can imagine. So when you pull out the shadow switches, none of the copper or anything here, it gets pulled out and stick on the switches. Then you have failed the mission. So I think I actually did solve that part of the quest. So now I can try and inspect my little shadow switch problem. This is the one that is not working. Those works, and this one is the stand-alone switch, and it is for some reason inside this piece of metal, but this is a kind of stand-alone kind of thing. I think the reason for that is they're just too close, and the stand-alone ones, they are a little bit wider because of this piece of metal. I don't think you really need this piece of metal. I don't know, oops, exactly what that is doing. Probably holding down this piece up here, because there's this little piece of metal here is the click and hold for that one. So it's probably up that end. I need to look for my problem. I think I need to pull them completely to pieces, and I was really not hoping to do that. I think this little piece of isolation material here is just to hold everything nice and straight. For this is to create that height you need. See, down here, this is the switch height, and this is the height they want over the circuit boards for some reason. So I better remember to put these back on. So I think I figured this out. See this little hole here? This is where the little holdy plastic thingy was supposed to be. This spring fell out. So that is somehow mounted in between each of these units. There's only one spring needed to do the little lock and release kind of thing. And that is this little piece of metal here that goes back and forward. So here at the outermost two holes here, there was supposed to be that little plastic part you can see down here. Those two switches here, they work because of that plastic part that is correctly mounted there. And this is what we are missing for the last one. As you can see here, there is no plastic part that goes in here and hold it correctly into the position. So that means there's no way I can fix this. I need to go and see if I can buy some new shadow switches, probably. I do realize there's definitely no way I can fix these mechanically, no matter how I pull them apart and put them back together. I mean, this is definitely never ever going to be a solution. I think my solution is to go and buy some new ones. And I went to RS Online and found some Alps. And this is the part number. And I believe they look very much the same. So now I'm ready to continue my little switch replacement. And I really want to show you something really, really embarrassing. First I thought that, hey, let's just skip this little part and go right to the perfect solution, and then I would pretend to be a lot smarter than everybody else. But I mean, I think sometimes it also has its its fun moments to show you all how stupid I can be as well. Oops, here we go. I mean, when you look at pictures and stuff, and it's just way too good to be true. I mean, it's just not going well, right? So you see the difference in size. And I didn't check. I was just too busy, and they didn't present any measurements or anything. It's just this picture, and I just thought, hey, this is the right size. So I ordered a bunch of these, and they are, of course, absolutely useless. And then I thought, hey, let's do the measurements and then do the datasheet check and all that kind of stuff. And then I bought a bunch of these. And now I believe this is exactly the right size and everything. It even feels like it's the same force and travel, and everything is perfectly fine. So I will, of course, put these in. It's just a little bit annoying. It took me two, little ordering. Yeah, okay, you can laugh. It's perfectly fine. I mean, let the one who never did this throw the first stone, okay? It turns out there's another little challenge. It just keeps popping up with challenges. Remember those little pieces? This is actually circuit board, and it's in a very special thickness that is made to lift up the switches so that all these fits perfectly fine. And of course the new switches, they're exactly the same as the old ones when it comes to the height offset and the little thing here at the back that holds them out. I mean, if you really look careful about everything here, all measurements is exactly the same. And the little plastic things down there, see? That one there, that makes the height. That's exactly the same as well. You know what I could do? I could put in a link to the new one in the description, so you will be able to order exactly this one in case you want to perform service on anything like this. Because once you get to this one, you could easily figure out all the different with more contacts and all that kind of stuff, right? So my idea is I would put these height holder things on the two furthest apart, and then I will self-align the other two to have exactly the same by using a little magic here on the top. I think that is what I want to do. Oh, I also need to do it right like that. Interesting challenge. So I'm quite happy with the result. It's really working super good. And all the cleaning of my potentiometers here, see? That was so nice. Now I have DC offset. For this to work, you need to pull, and then you can. Real nice, I think. Yeah, I saw a little tiny little, oh, see? Tiny little noise. Oh yeah, about the duty cycle output, see? I don't know. What can you use this for in the sine wave? And then the inverted goes the other way. That's quite funny, right? But if you select square wave output, obviously now duty cycle makes a lot of sense. And then of course now inverting is a good thing. At the moment here I'm using the output pulse, that one down here, and this is what I'm tricking on. And this is also really, really good when you're playing with different waveforms and different amplitudes. Then you see you still get a nice and stable. Okay, yeah, anyway, I think I'm super done with this one. Only one tiny little thing that was bothering me all along, and that is of course this little missing plastic cover. Look what I found. I found one from another switch, or another knob, and I could just cut away some of these little plastic things. And now, I think, yes, I did this before, and it says sort of click, and then, see, it is now fixed. Ha ha. All right, thank you very much for watching. Please come back again soon. Bye bye.